All right, good morning, everyone. My name is Logan Lohr. I am the project manager for G.A.L.S for this Eastgate Development Project. With me today, we have Roberto Alanis, who is responsible for transportation. We have Abraham Steinbeck, who's also responsible for transportation, and we have Ryan Gibbons, who's responsible for transportation. I will be handling the structural components of this project, and going forward, let's dive into the background of the project. So, the site is located east of Valparaiso University, is in between Sturdy and Stillhavie Road. The site's characterized, it's got some vacant lots. There are current residential housing there. It's also home to the university's baseball field and practice fields. And there is also a creek that runs down the east side of the property and a wetland in the southeast quarter. So, like I said, I am responsible for the structural components of this project, and so I'll be going into some of our responsibilities for that. We've been tasked with designing a retail and or commercial building that has a square footage of at least 16,000 square feet. We've also been tasked with the design of a senior living building that has a square footage of at least 20,000 square feet. And as well, we need to also provide a covered outdoor space that has at least 2,000 square feet. And we have to design the corresponding foundation for each of those buildings. So here is a preliminary design of what the senior living building might look like. As you can see, the second floor is offset slightly. This provides the covered outdoor space that was required, and it also provides a balcony on the back end of the building for the residents of the second floor. So the typical floor plan here, there's 24 units. They are 30 by 30 each. We have selected this as our only layout for the residential building. We decided to do this to maximize the amount of accessibility. Since it's senior citizens living here, we want to make parking as close as possible and allowing for the least amount of walking distance to each residence. So going into the structural components of this, we've selected different materials. The first one being timber. So each of these here would be the base spacing with columns and then beams and girders. So we've assumed that a typical spacing for timber material would be around 15 to 20 feet. This can pose some issues considering that we might have some columns in between that doesn't quite work well with the floor plan. So that would have to be taken into consideration as to whether or not we want to select this as an alternative. Another material that we've selected as a possibility is concrete. As you can see, we have slightly longer spans. This can span our 30 by 30 rooms much more easily. It's still in some of the larger areas would require some extra columns, but it's still a possibility. And then finally, steel with a longer span we've decided based on the amount of depth of the beam. I ran a preliminary calculation for a concrete beam, and just based on some assumed loads that it would give us too tall of a beam for longer concrete spans. So that's why we selected steel as our longest span. In a similar manner, we have our commercial building. This will be a single-story building. The layout has already been decided, and we're just going to consider different materials. The first one being, this is the typical floor plan. So it's a 58 by 47 foot unit. There's 6 units. That gives us the 16,000 square feet that's required. And so the first would be a concrete structural. So this would also require some columns in the middle just to meet the span requirements. Could potentially cause some issues depending on who owns the space and what they would like to, how they would want to lay it out. There's also steel, which gives us our longer spans. And then finally, we have masonry as an option. So these walls would be load bearing, and then these would be steel joists that would support the load of the roof. So for our future work, we need to obviously select the alternatives and then determine the load distributions based on occupancy use, whether or not it's going to be residential living or a corridor walkway would have a different load distribution. And then based on those load distributions, we have to design the structural materials and the corresponding span lengths and column spacings. And then once those are done, we can design the foundations. And then after it's all said and done, we can put together a cost analysis. So I'm going to hand it over to Roberto, who's going to talk about the northern half of our transportation.
So as one of As one of the 2 transportation engineers, I was tasked with developing a new road that would connect Sturdy Road and Sohavy while allowing for pedestrian facilities. Alongside, I would have to redesign the existing intersections at Sturdy and Sohavy. Additionally, I was to develop a new parking lot for the new development that my comrade here was to be designing. This is a picture of the site just east of Valparaiso University. This is my alternative 1. It is a more simpler alternative, allowing for a connection at the already existing intersection at Boilermaker Court on Sohavy Road. Alternative 2 is a much simpler alternative, allowing for a perpendicular intersection at Sturdy Road and a perpendicular connection at Sohavy Road. Alternative 3 is more of a wavy road, but it would allow for more space, more breathing room for the vehicles coming in from the northern section of Sohavy, the Menards and the shopping centers and whatnot, coming southbound from the northern portion of Sohavy. These are my 3 intersection designs alternatives. I went with a signalized, a roundabout, and a 2-way stop intersection. The roundabout would just make things much simpler would allow for a more smoother transition between road to intersection to road. And the 2-way stop is essentially what is already there with the addition of the new road. At Sohavy and Boilermaker Court, I went with the same 3 different alternatives with the addition of extra facilities on the eastbound road due to the awkward angle that the road meets the new intersection. These 3 tables come from the Valparaiso City parking ordinance. And the objects highlighted in yellow are how I managed to design my parking lots. It was determined that for the assisted living, it was required 1.5 spaces per every dwelling unit. And as the assisted living space has 24 living units, it was required a minimum of 36 parking spaces. As for the retail building, we required 5 spaces per 1,000 square foot. The building is 16,000 square foot, so that is a minimum of 80 parking spaces. And we are required a minimum of 2 and 4 disabled parking spaces respectively. So this is my proposed parking lot design. The retail building has 92 parking spaces with 2 of them being, 4 handicap spots and 2 of them being handicap accessible. And the senior living center over on the right has 47 spots with 2 handicap spots and both of them being van accessible. I designed the spots to be 10 foot by 20 foot just to account for the seniors as they are older people. And then the loading zone down here at the bottom. For the future, I am looking to refine my alignments with more specific numbers, work on a traffic impact study and determine the level of service so I could then reduce my alternatives and hopefully make a proper choice on my final design. Next, I will be passing it on to the transportation engineer of the South.
Thank you. So my project here is on the south side of Eastgate, which is right across from Gellerson, right across the street. As you can see in my preliminary design and scope, I need to put in a bike path and a pedestrian path as well for accessibility. There also needs to be a new design of the intersection and a total new realignment. With that, a parking lot also needs to be added as well. Moving forward, I collected a data collection for my traffic impact study design. With that, I went on the VU website. I looked at the total attendees that were at the Valparaiso baseball games. And from there, I was able to gather my data collection with the attendees. I decided to use an 80-20 ratio. Because of this, There actually is no traffic impact study on baseball fields in the traffic impact study. So this is a best estimate guess that I thought would best fit our scenario. From here, I ran the traffic impact study with Vistro. As you can see, I got a level of service on B before, and then after existing, I got a level of service to C. Now, for my first alternative, I decided to use a signalized intersection. I did this because the previous intersections before this are all signalized. So the intersection going into Walmart is signalized, and I thought that it would be best fit that everything would run smoothly if they are all the same. I ran with Vistro and I got level of services both with A. They're all 12-foot lanes with 20-foot radiuses. Here, my second alternative is a three-way stop. As you can see, I have a level of service of B during the peak hour. However, it's interesting that the exiting is a level of service of A. And this is because during baseball games, they typically end around like 9 o'clock, and that's out of the peak hour. So because of that, it's out of the range of the peak hour, and there's less people driving to and fro to stores, allowing for an easier exiting. Here in alternative 3, I decided to use a roundabout. I decided to try this because it's safer for the environment, less accidents are proven in the studies. So I decided to run this using Vistro. I got level of services with A for both entering and exiting. Here in my parking lot design, I decided to use 113 spots. I will dig into that later in the next slide. With that here, as you can see, there's an entrance on the east side, and there's an entrance here on the more north side. So there's an entrance on the south side and the north side here. With this is because I wanted to connect to Chapel Drive, and I also wanted to connect to the new Silhavy alignment. Here, like what our previous engineer said, thanks to the city ordinances, that's where these tables are from. I decided to use both parallel lines and 30 degrees lines as well. In order to get these, you had to go out to the baseball diamond to connect and to count the number of spaces and the number of bleacher sections. It was 1 space for every 4 foot of bleacher. I counted 450 feet of bleachers, so 112 and a half of spots, so 113 spots. Right here for my first alternative design, because we have 2 transportation engineers, I decided that I would connect my alternative design here to Roberto's up here on the north. And with that, as you can see, the main issue here is there's a wetland there. And I thought it'd be best to go around it so we don't have to comply fully with EPA guidelines. However, they will still be a factor. With this, I decided to dead end Silhavy Road there, so we will not have to worry about traffic, which is why it's a 3-way stop. With that, I put parking on the northwest side of campus, right there on the baseball diamond. On my second alternative realignment, I decided to move things around just a little bit. So I moved the parking from the northwest side to the northeast side of the baseball diamond. From there, I am no longer connecting to our previous engineer's realignment. It's a total different realignment here, curving in and out. It's avoiding the wetland area, and I'm still using a dead end. So my future work that I need to complete still is a pedestrian and bike path need to be implemented. A best alternative needs to be selected, and a best alternative realignment also needs to be selected as well. I'll be moving forward to our water resource engineer, Ryan Gibbons.
Thanks, Abe. All right, so water resources scope. I had some required tasks. First, I had to look at the existing conditions on the site. That included looking at the topography for the site and also the soil conditions on the site. I had to use the TR55 method according to the Velpo manual. I need to use that because my watersheds are both over 5 acres. I then had to get my water quality control volume and my flood control volume. Water quality control volume is the volume of water that we're going to attempt to reduce the phosphorus in by 65%. Flood control volume needs to be calculated for large storm events, particularly 100-year storm. Water quality control measures won't be able to hold the volume for 100-year storm. So that is why we need flood control volume 2. And then obviously I need to get alternatives also. This is what I've completed so far, pretty much everything in the last previous slide. Completed my soil survey. TR55, I used hand calculations and the WIN TR55 program to get the peak flow. And I was able to get my flood control, water quality, and alternatives. These are my 2 watersheds. I decided to split them up at the creek that goes between them. As you can see, there's a lot of soils on the site, so it's a little complicated. This is alternative 1. Keep in mind that these are not to scale, and the location of buildings and parking lots are subject to change. And these arrows that I use to represent the flow will represent some sort of ditch system to get my water to my different measures. I'll have to do research to decide of whether or not they'll be normal ditches or if they'll have to be vegetated swales. That will depend on how much phosphorus my rain gardens are able to filter out. So for my first alternative, I have 1 rain garden going to a detention pond. And then any excess water that is not infiltrated inside of the detention pond will go through a vegetated filter strip before it goes into the stream located on site. So it will all be filtered before it gets to the stream. Second alternative, I decided to put the rain garden right up here. And I will for sure put a vegetated swale right here, a long one, to a detention pond. And the detention pond will eject any excess water into the pond right here. Alternative 3, I decided to go with 2 rain gardens, 1 for the 2 buildings and parking lot, and 1 for the parking lot for the baseball field. Both of these rain gardens will go into the detention pond. And once again, excess water will be filtered through a vegetated filter strip before it goes into the pond. Future work, I'll have to do my design calculations, that is lengths, widths, depths of all of my ponds. Alternative selection, after I do those calculations, I'll have to select which alternative will be the best. Optimization, once I select my alternative, I'll have to optimize that design so that it's cost efficient and it's also effective. Roadway ditch design. So we do have 2 transportation engineers on the site. I will have to do ditch design for one of the proposed roadways. This ditch system will connect in with my other ditch systems that will go into the rain gardens or detention ponds, whichever alternative I pick. Plant and seed research. I have to figure out which plants and which seeding will be best for my rain gardens and vegetated swales so that I get the most, I filter the most phosphorus that I possibly can. And then I'll have to do a construction cost estimate for excavation costs and whether or not I need to transport soil on or off site. With that, that concludes our presentation. Here's our references. And does anybody have any questions? Professor Weiss. From the road, I mentioned here that I will have to do ditch design for the roads. I'm not exactly sure which alternative will be decided on for the roads yet. So I did not decide to put it into my preliminary alternatives because I didn't know where the road's going to be. I did mention that I will do it at some point though. Okay.
It was something I had thought about previously. But the reason that I didn't entirely do it was I figured it would be much easier much more simple for everybody to enter through a singular space, eliminating the possibilities of, people who are, I suppose, not well acquainted with the environment that should go on in a more residential area to be crossing through. What I thought was I didn't want people going to the shopping center, speeding or, moving a little quicker when there's older people in the area. Yeah. The
So my initial thought was to just cut it off there. That way it eliminates that whole Silhavy alignment, because that's the main issue. That's the whole reason of this project. So therefore I just wanted to connect it upwards on Silhavy. But I have thought about it. I have some preliminary designs I have not put on here because I want to run the calcs before I present them. But with this, that was my initial thought, because it still would not be an issue if you had traffic going up based on the level of services I ran with Vistro. So it would not be an issue with that, with traffic going down and through to get to those lower hotels. Sure, yeah. It's not drawn to scale, but yes. Will do. Thank you. Forward or backwards or?
I did. I just didn't include them in the presentation. I have them in a spreadsheet on my computer right now. Off the top of my head, I do not. I apologize for that. I could meet with you later and show you those if you would like, though.
So 2 lots then. And it was a consideration. But when speaking with the water resource, it was determined that it would be a more simpler idea to have 1 lot. But it hasn't exactly been struck out. The idea hasn't been exactly eliminated, I suppose.
As you know, if you go out to that site and you look to the west,
Right. Fair point.
The senior living building is the two-story building and the commercial building is only one story. So the residents of the second floor have a balcony that would be on this side, so they would be able to see the chapel from their balcony. Jolie?
It was 30 degrees, but let's see here. I guess I can go here. So your question is more of why I decided to go with angled parking and parallel parking. So my thought process on that was just to have more bang for your buck, essentially. So you're gonna have more parking spaces in the same area. That's why. Thank you.